Siddharth, do you want to give us a quick overview on the scalable configuration issue?
Yeah, I can do that. Can you hear me?
Yes, I can hear you.
Okay, perfect. The issue at the moment is that all current network-related settings are stored in the ledger header, and this isn't a good place to store, the Soroban settings because they can be quite large. I think the current estimate for metering alone is 1 kilobyte. So before we go through the approaches, I'll mention that they all assume the use of dedicated ledger entries for storing settings, as described in CAP 46-9. And that the settings will be created on protocol upgrades. The only differences in these approaches are how the settings themselves are upgraded. So in approach 1, which is described in CAP 46-9, this requires a mechanism for validators to introduce and distribute setting upgrades directly through the overlay. The validators will then vote on the hash of the flooded settings. Approach 2 allows users to use Soroban to introduce possible setting upgrades into the system using arbitrary ledger entries, allowing validators to vote on one of these entries to overwrite an existing setting. We use Soroban here so accurate fees will be charged for the larger operation and ledger entries that will be introduced. There is still a question of how the user will interact with Soroban. We can add a new operation, add a new option to the invoke host function app, or rely on a smart contract itself to create these entries. Approach 3 is similar to Approach 2, except that a new Stellar Classic operation will be used to create the entries that validators will vote to use. To make sure this operation isn't spammed, the idea here is to make the operation withdraw a large amount of XLM from the source account. But this idea needs some additional work to guarantee that the operation always has a sufficient balance for the withdrawal once the operation has been flooded, because you don't want the operation to get flooded and then fail, because the network will have already flooded done the work to flood the operation. That's a summary of the 3 approaches. I know there are opinions on all of these. So, this is Tomer. Do you have any opinions on what would you prefer?
Sid, I have a
Yeah.
question. So, can you tell us a little bit more about what is stored in these network configurations, like concretely, and why is it important to preserve that data?
So, for example, for metering, we have different parameters on how specific things get charged, and so the structure will have say a bunch of U64s that indicate how specific settings should be charged, and that is what Soroban will use when deciding how metering should be used. But we want these settings to be configurable. That's why it's not just hard coded in Soroban. The settings will be stored somewhere, and the validators should be able to upgrade the settings whenever they want, if all the validators agree. Does that make sense?
Yes, it doesn't sound like something that would change frequently between 2 subsequent ledgers, right? But it's more something like, when we're going to upgrade to protocol version Y, then we need to make that update. Am I correct
Well,
here?
we don't want to tie the upgrading of the settings to protocol upgrades, right? For example, right now we can update, I believe, like the base reserve if we wanted to without updating the protocol, right? So that we want this to work the same way. And while I agree that we won't update the settings very often, I wouldn't be surprised if we did it twice in this specific protocol version.
It's just generalizing what we're already doing in the ledger header to a much larger number of numbers, because it's in a potentially unbounded number of numbers. Although it's not like enormous. It's not thousands and thousands of entries, but it's probably tens or possibly as much as 100. So
Does it make sense to do something in the like of having an optional field in the ledger that would have that data, and in any subsequent ledger header, just say, hey, in ledger number XYZ, we've last updated these parameters.
So, I mean, that's how I think what you're describing is how like the upgrades currently work. Like you submit the upgrade to upgrade a specific setting. The issue here is that the settings can be quite large, right? So it's not it doesn't like sending a 1 kilobyte XDR blob in the current mechanism wouldn't work. It actually wouldn't work at all with the current XDR because we have a limit of I think 128 bytes per upgrade. But which is why we're exploring like a more scalable solution.
Ed, can I ask you a question about the other approaches that are not approach number one here? In approach number two, for example, you've got two things that are in play. One of them is sort of promulgating the proposed changes, the set of options, and one of them is a consensus vote. If people vote on two different config settings, what happens in approach two? Like there's still a consensus conflict resolution problem, the same as you would have in approach one, where there's this arbitrary, take the largest upgrade choice that the consensus layer is doing. In approach two, what does the consensus layer do if there's two conflicting votes?
It would be the same as what it is today, right? Like if there's two different votes on, say, the base reserve.
I don't actually know what conflict resolution is on the base reserve right now. But my point is that it is currently happening in the consensus layer, and in approach two, it sounds like you're trying to take it out of the consensus layer. So then,
No, I want to say that all the approaches actually are the same in terms of voting. Like in any case, validators would vote on the hash of the upgrade set, of the config upgrade set. And the reason for that is that, well, we don't want to bloat SCP values as well. Because we have plenty of them, and even the upgrades are a rare event, we don't really want to have huge spikes during this rare event. So voting always happens on the hash of the config upgrade set, and the default mechanism for consensus is that if you don't agree with this upgrade, you vote against it, and then if there is not enough votes, then yes, it won't be
yeah. But so all of this happens very
everything
quickly. All of this happens very quickly during the voting round, and I'm not concerned with the like I object to this vote, because that's not likely to happen very often unless someone just doesn't schedule their validator. It's the combining thing. If validator A chooses ARMS upgrade for upgrade set A and validator B for B, then when someone hears those two, or nominator hears those two, or whatever, they do a value combine, right? They do a CP value combine.
Yeah, these are not combinable, right? Like the unit of voting for the config upgrades is a hash of the whole set of the upgrades that need to be upgraded atomically. Like it may
so any conflict just fails immediately.
Any conflict just fails immediately. So we don't try, like in option one, I guess it is possible to do something weird there, or we can have some fuzzy matching of the upgrades. You say like this operation should take 1,000 units of gas, and I say it should take 1,001 unit of gas, and maybe it doesn't matter in the end, but it kind of introduces too much unnecessary surface for potential issues and bugs and whatever.
Sure, I'm just saying that looking at the document that I'm reading right here, it says that the CAP picks the largest upgrades, which is arbitrary and requires some sort of conflict resolution, and may want to only vote for a specific hash. So that sounds to me like a conflict resolution mechanism, but I'm just trying to clarify whether that's real, or whether it's
maybe docs are
one, or
maybe docs are related, but I think in all approaches idea for voting is the same. Like we vote on the hash of the whole upgrade set, and validators have to agree on this hash exactly. The question is only how we distribute the pre-match of this hash.
Okay.
Sid, I do have a question on kind of like the implementation burden. Like, what is between the different approaches? What is, what's the low hanging fruit, and what requires like additional mechanics?
I would say approach 2 should be the simplest. Dima, correct me if I'm wrong, but it shouldn't be hard to, add a function Soroban to, create these entries, and then, then the like any mechanism to interact with that function should be simple, either a new operation or the invoke host function up. Or I think using a smart contract is a little more complex because I think there's some there are more details around that, but I don't think I think in my opinion approach 2 is the simplest. Approach 3, yeah, I think we have to be careful to make sure that it's not spammable. And approach 1 requires work in the overlay in the consensus layer.
And is the reason approach 2 is the simplest because it reuses the metering mechanics that we have in Soroban?
Yeah, that's the only reason we were putting it in Soroban itself.
So to add to that, I would say, I mean, approach 1 is not hard either, and there is a prototype PR for that. And both approaches, I don't think there is too much work anyways. The spam problem is there for Soroban too, like we figured it out discussing with Sid. Concerns, for example, WASM transactions that install WASMs, they can be pretty big too, and we don't want to flood them for free, basically. And I guess in this sense, like it's maybe not necessarily a very easy problem to solve, but we need to solve it anyway. So kind of option 2 just piggybacks on this, while with option 3, I guess we need to change something in classic mechanisms to make it work properly. So yeah, I kind of agree that probably 2 is the best in the long term, sort of like just amount of work, additional work required. Yeah.
Could you speak to the complexity of the consensus change that's described in approach 1? It says the consensus change it would be complex. Is that like because it involves the item fetcher? Because we would have to have a second, like the way we do TX fetching. Is that it?
Yeah, I mean, it's again, I haven't haven't written this point about consensus layer complexity. I don't think it's complex per se. It just literally reuses the TX set logic, but TX set logic is arguably not very simple either.
Yeah, no, it's not.
Like,
if this involves replicating TX set fetching.
Yeah, I mean, on one hand, it's trivial that we copy something that exists, but we are copying something complex. So maybe it's really better to just use normal ledger mechanisms to put these entries into ledger and not bother about adding yet another flooding problem.
So the one question I have about that is that the consensus module has to actually be able to judge when it has a given hash, right? If there's a vote for hash X, it has to then ask the ledger, hey, does hash X actually exist? Because I'm not going to vote on a config setting that I don't have, right, like in the ledger, right? So this is just moving that question from item fetcher over to a ledger inquiry, and that's a synchronous ledger inquiry in the middle of consensus, right?
Yes.
Okay.
I have no idea if this is a big problem or not. Hopefully.
Are we okay with that? I mean, that's kind of the risk in my mind, but maybe that's okay. I think that's probably less pain.
Yeah, the thing that is kind of annoying, I mentioned that in the doc with the approach that relies on consensus, is that we would have to secure the upgrades in some way. Right now, upgrades, because they're small, we don't actually they are not actually signed. So values in SCP, they are actually signed, so that you if some validator goes rogue, you can basically blame who introduced that the value that is kind of spamming the validators. So you can basically decide, okay, I'm going to remove this validator from my quorum set. That's kind of the idea with the signature. Upgrades are not part of this because it's today they are small. So if we start to have the reason for upgrades not being included in the signed payload is that there's an option for validator to remove the upgrade from the value if they don't agree with it. So so that basically you can still close ledgers, with transactions, even if there is no consensus on the actual upgrades. Which I mean, we didn't have so much of those problems until now, where there's like a broad agreement on like, for example, if you want to upgrade the network right to a specific protocol version, there was no contention. I think we'll have potentially more contention in the future as we think of network parameters that maybe are impacting certain contracts, right? Like as every time we change like fees, or like the metering schedule, right? Like we're going to cause maybe certain contracts to become more expensive. Therefore, there is maybe a higher chance of disagreement between validators. So I think this the chance of conflict is higher in post Soroban, and that's why I think we may have more situations where some validators are going to say, hey, I don't agree with this thing, so I'm going to drop that upgrade. And then until the conflict is resolved, you don't want to be in a situation where the network is not agreeing on basically anything, right? Anyway, so that's kind of why you can drop those upgrades, and right now they are not signed. So we would have to either make them signed if we want to make them bigger, or just not, keep them small, and that's kind of the option too. Hopefully that makes sense to people.
So I do have a question that relates to the user experience of changing the configuration. Right now, validators, just have like stellar core commands to control this. Is the idea to maintain the same experience across all of these different approaches, or do different approaches mandate different user experience?
I think I can answer that. I mean, it's easier to arm an upgrade for a hash. Like it doesn't require any changes because hash is small. Like if you needed to distribute the whole upgrade set as an option 1, and that's doable, but it's annoying. Like it's annoying to do this as a for command. You would need to maybe extend the command interface to take a file instead of just a get request or something like this. So approaches like to and following simpler in this sense because it doesn't require any EX changes. Like we say, hey, you want to upgrade to this set of configs, this hash X. Here is a link to the ledger that actually contains this entry. So I think the distribution is kind of cleaner in this. It's easier to arm these upgrades.
But it introduces the transactions that needs to be submitted.
Yes, someone needs to submit a transaction. This is true.
Yeah, so the UX does change, right? In all approaches, right? Because in the approach 2 and 3, you need to submit this operation. But in approach 1, the initial set of upgrades needs to be distributed as well, right? I guess that would be maybe another stellar core command that the validator would submit, and then that's how that set would be flooded.
Right, but to be honest, I do feel like approach 1 is an extension of the current experience we have, which is, the validators will coordinate. The validators always need to coordinate, regardless, outside of the network, right? So, they coordinate on a channel. Right now, Justin tells people, hey, if you want to upgrade or to change this value, this is the command you use, right? So maybe the mechanics are going to be a bit different. We're going to say, hey, this is, an XDR, take a look at it at Stellar Lab or SDC or whatever, and this is the hash, vote on it. So it's still like you don't introduce like another step of submitting transactions to the network.
Well, only one person needs to submit a transaction. It's not like validators. Once the thing is populated, it's basically like today.
Yeah, basically, whoever initiates the upgrade should send the transaction, which I don't think is a huge deal, because they need to prepare the data anyway, which is like just sending a transaction.
Got it. Okay, that makes sense.
Yeah. By the way, this closes a kind of a potential, communication problem that we have today, right? Like today, when we, for example, when we as SDF say, hey, we are proposing to upgrade the network to version 19, right? Like we did last year. People look at that message. Is like and it's not signed. We don't publish that with digital signatures or anything. So in theory, you could imagine somebody faking, us, and then getting people to vote for something else. I think the chance of that again increases as you increase the complexity of those things that people are voting on, and the benefit of having the entity that is kind of championing for a specific change is that because this is actually an actual transaction on the network, it's also signed by the entity. So that's kind of one of the extra free benefit from option 2 and 3.
So essentially, like configuration change proposals become on-chain activity.
Yeah. And actually, so that's something I wanted to kind of maybe, because we didn't talk about that too much, like in the doc, we only kind of mention it, that option 2, like one of the things I think that this opens the possibility for in the future to have point the validators to like ledger entries that are controlled by DAOs, so that you can, for many validators, there's a concept that we discussed before, right? That is actually in a paper that was published a few years ago about the notion of governing and non-governing validators. And I think this, for certain things, this may actually become more interesting, in the context of DAOs that are not the tier 1 validators, that are kind of managing certain aspects, certain parameters that of the network, and then the validators that are interested in actively participating in this, of course, they would not just blindly vote for those things, but otherwise other validators just might do that, right? For those maybe not as coupled to network operators, right? Or maybe you will need like additional voting or something, right? And you want that to happen on chain because you want more transparency or something, right?
Got it. So yeah, it does sound like there's some added benefits to approach 2, and it seems like from an implementation perspective, it's fairly simple. Do we have any concern about it's not immediately obvious that stellar configuration changes should be proposed on Soroban? It feels a bit like we're using just Soroban because it's there. And I don't find it offensive, but like, can there be issues from it and things like we want to do like in pure stellar, and now we're introducing them to Soroban?
I think this kind of ties into like subtopic I wanted to talk about, is whether or not we are separating Soroban operations into like different operations in the transaction, because currently we have just one code invoke host function that does a bunch of stuff, and with these changes it would do even more stuff. So I'd say using Soroban is just an implementation detail here, and nothing prevents like an option 2 from being a separate operation. And also we may want to do this to all the operations anyway, just to have a single flat hierarchy of things you can do to Stellar, which basically would make it pretty opaque in terms of like how exactly transactions are being executed. I think improves the UX somewhat, in my opinion.
So the derived question here is whether we want to split the invoke host operation into like multiple types of Soroban invoking operations.
Yeah, right. Like in this particular case, like I feel like there is a strong case for making it a separate operation with very explicitly name like containing internal assumptions that people don't randomly submit it. And for all the existing operations, there is the same consideration. I don't know if people have any opinions on this.
Will it be accessible from the Soroban environment in addition to being accessible through this dedicated operation?
No, I mean, the thing about the current invoke host function transaction operations that annoys me, and which is why I'm proposing this, is that we are not actually invoking a host function in the same way you can invoke it on from the contract. Like they are divergent. They like the host functions that we invoke from Stellar Core are not the same host functions that are more invoked from contract. So the name doesn't make too much sense. I mean, even though initial intent kind of made sense, but the way implementation and requirements ended up, they are not quite consistent, and I'm not convinced we should keep it as in this host function. And we could just be a bit more explicit and just say the operations are named after the things you are doing without involving the word host at all. Yeah, my opinion on this.
Yeah, I think the original intent was just to make call uniform, and I think we may be paying a fairly high price to try to make two entry paths to call look the same. We're sort of orienting everything in order to make that one path try to reuse code.
Well, I think it may be like this is more related to. I saw there was like if we have a dedicated host function for all this stuff, I agree. Maybe we need to think about this. But like, I'm not actually convinced that this is the necessary to have anything first class for those network upgrades inside Soroban. Like, I think we should be able to point to basically any Soroban state should be considered valid for like as long as we can, like I was saying in the doc, like it's basically a byte, a byte array that we happen to be able to decode, using because it's some XDR, right? That we can understand at the network level, but that from a Soroban point of view, I think it's just a byte array. And if we do it like that, there's nothing special about like any of that stuff.
Okay, so this is an important point that I didn't understand. So from the approach number 2 perspective, we're not actually introducing changes to Soroban in order to facilitate this?
So what is in the doc right now, it talks about having special ledger entries that are like, so you need like a host function to basically manage those special entries. But I'm not, when we originally discussed that, I didn't think we would actually have dedicated ledger entries for as input to the upgrade. I thought that at the end, yes, when upgrades are actually, when those network settings are actually active, yes, there are special entries on ledger. But in terms of like did they get fed into the upgrade function? That I don't think we need to have dedicated ledger entries, with that specific format as input.
That point in the doc was more to specify that it's not a config setting entry. I guess it wasn't clear what it actually is because I wasn't spec'd out. But what Nico's saying is probably the best way to do this, where we specify that for an upgrade, it'd be a byte array of a config setting entry or a byte array of a vector of config setting entries, right?
I'm not sure I'm getting the point because we don't have an entry like that.
It would just be I think what Nico's saying is it'd just be a contract data entry.
It's not a
And
contract. We don't have a contract, so it cannot be contract data.
You can no, like it's anybody, like, as part of this, right? Like you can imagine. That's why I think, like, if you think of in the future, you want to have some DAOs doing that. Like it's just a special case. Like if I want to, in the first iteration of this, the way you would do it is you have a dummy contract, that has like a state, associated with it, that is just a single, that has a single value in it, and that allows you to basically, as a user, I can persist, I can, like kind of like a balance, right? For a token contract, but instead of a balance, it's basically a binary blob. And then in the upgrade, that's how you get it on the ledger, right? And then the upgrade just points to that specific ledger entry that contains the binary blob of interest.
So what you are suggesting, we would have a contract specific host function.
No, there's nothing specific to this. It's just like, in order to construct.
But then how would we vote on it? Like it has to be special, right? Like Paul had a similar proposal in option 4 for that. There needs to be a way, like since we are voting on a hash of something, you need a straightforward way of finding this hash in the ledger.
Yeah, that's why you can point to any arbitrary contract data, right? You just need a ledger key.
Yeah, this
But then
case,
we would
you
need to
wouldn't
vote
vote
on
on a
ledger.
hash. Yeah, you vote on a ledger key.
You would vote on a pair ledger key hash, probably, right? Like maybe you can make it work with just a ledger key, but like that, for now, I think it's ledger key hash.
Right.
Maybe we need to, we need to maybe like sketch that a little bit so that I can.
So basically, you would vote on, say, I mean that's quite inefficient, right? To vote on ledger key. I guess the best you can do is contract ID plus some data ID in agreed format. Hash ID, but
So I think this has been super informative. It sounds like there's a very strong bias towards approach number 2 here. And there are some details that we need to figure out, like whether this is actually something that's special cased in Soroban or it's just a general ledger entry, and then the validators as part of the upgrade process just point at this ledger key. So I think we can take this conversation offline about the details, and if needed, we can bring these up in one of the next meetings. We have around 20 minutes left, and so before we go on that, Siddharth, do you think we have enough to keep prototyping here?
Yeah, we should be good.
Okay. So we don't have a lot of time. We have 20 minutes, and Garand is here today to start talking about state expiration, which is a very big, hairy topic. So Garand's going to give a very brief overview about this today. If we have time, we're going to do Q&A. I imagine that we're going to be talking about this specific issue a few more times. So no big decisions will be made today. Garand, the stage is yours.
Yeah, so I guess we don't have a ton of time, so I just wanted to kind of start out with the general motivation and then talk more about the interface, and then we'll leave the implementation details to probably future conversations. So essentially, the issue we're trying to solve with archival state is this issue of unbounded ledger state size. At least right now in Stellar Classic, the number of ledger entries we have to store is growing, and there's not a strong incentive for users to delete entries. Additionally, a large amount of those entries that exist on the ledger are either outdated or just won't ever be used again. For instance, we have a lot of claimable balances that are more spam-like entries that aren't used very often or won't be used at all, that are taking up this ledger space and increasing ledger bloat. And so for the healthy scale patterns of the network, we want to be able to essentially cap ledger state size and not allow for this arbitrary growth. And to do that, we want to essentially delete entries that aren't being used, but somehow not delete and keep the entries that are being used often. And so in order to do that, what we do is we want to implement this concept of rent. So essentially, for all Soroban smart contract data entries, the data entry will have a rent balance, which is some amount of XLM that is reserved for that entry to pay a rent fee. And then as that entry lives on the ledger, it will have a rent fee deducted from that rent balance. And then whenever that entry's rent balance goes to zero, the entry is deleted from the ledger, and it's as if it never existed before. Now, this is obviously, it opens up some issues, right? So imagine you have a wallet or a balance that stores a lot of tokens that are valuable. You wouldn't want this entry to be permanently deleted and lost just because you forgot to pay rent and forgot to up your rent balance. And so instead of, even though the entry is permanently deleted from the bucket list, what we do is we take that entry and we send it to a special kind of node called an archiver node. And this archiver node is essentially storing all of these entries. And then if a user then wants to use an entry that has defaulted on rent and then been sent to an archiver node, then what they have to do is they have to go pay a fee and then retrieve that entry from the archive node and then give that entry back to the validators. And then once that fee has been paid, the validators will then take that archive entry, put it back on the bucket list, and then this entry can be used as if it was never deleted. And so kind of the implementation details as to how this works is the archive is implemented in a Merkle tree-like structure. And then in order to restore an entry from the archive and then put it back on the ledger so it can be used again, you have to provide a proof of inclusion that this entry that you say was archived actually does exist in the archive. And so this Merkle structure is very powerful because it means that validators are able to check and make sure that the entry you say is in the archive is actually legitimate, but the validators don't need to store the archive. All they need to do is store this root Merkle hash, and then they are able to validate proofs that are generated from the archive. So kind of high level how this works is the validators themselves don't store any of the archive state and cannot produce these proofs. But the archive nodes do store the entire archive state and have enough information to produce these proofs. And so the archive nodes we kind of envision to serve a similar purpose as kind of Horizon, where they are supporting the validators, but are not directly involved in consensus. And so from an interface perspective, this has a couple of issues that we kind of need to discuss, especially when it comes to security. And so because we want the validators to store as little state as this archive as possible, they don't store any of the keys and they don't know what's in or not in the archive. And so if you can imagine an example, say we have like this token contract, right? And you have a balance on that token contract, but you don't use it. And so eventually the rent balance on that entry will go to zero, and that entry will be deleted from the ledger and then stored in the archive. Now, once you default on rent, from the perspective of the validator, it's as if this entry has never existed before. And because the validator doesn't actually store the archive, it has no way of knowing that this entry used to be in the bucket list or that this entry is currently in the archive. And so this means that if, say, the smart contract was to create another balance with that exact same address, this would be allowed, right? Because the archive, or because the validator doesn't know that this entry and this key exist in the archive, it will create and generate new keys, which means that we have this issue of key collisions, where you can imagine if this process was repeated several times, it's possible to have an entry with multiple different versions of that entry with the exact same key that exists simultaneously on the ledger and also in the archive. Now, for some types of data, these key collisions aren't that big of a deal, right? So if you can imagine if you have, say, a balance of some amount of token with your given key, and there are multiple different balances you have. So say you have 10 XLM in an account, and then that 10 XLM balance gets archived, and then someone sends you another 5 XLM, and then eventually that entry gets archived. With your key, there are 2 entries in the archive that correspond to your balance, one with 10 XLM, one with 5 XLM. But this isn't that big of a deal because both of them are valid, right? You can just restore the 5 XLM balance, spend that 5 XLM, and then restore the 10 XLM, spend that, no problem, because both of those balances are valid, even though they have the same key. But for some data types, that's not the case, right? So if you can imagine a smart contract implementation that uses a nonce value, So let's say that we have something like USDC that uses a nonce to protect against double spends and make sure that transactions can't be replayed. Say that this nonce value is something like 10, a non-zero value, and then gets archived. Well, now this token contract, when it needs to do something, the token contract will see that there does not exist a nonce, because from the perspective of the validators, the contract itself has no way of knowing what's in the archive because the contract is running on a validator and the validator doesn't store the archive. And so whenever the contract sees that there doesn't exist a nonce on the ledger, instead of going to the archive and restoring the nonce with a correct value of 10, what the contract will do is just create a new nonce with a value of 0. And so what you can imagine is, say that we have the correct nonce value, which is 10 in the archive, and this new 0 nonce. Because this nonce is incorrect and is essentially shadowing a valid version of the nonce in the archive, this allows malicious users to execute a replay attack. Because they can take a transaction that says, hey, if nonce is equal to 0, this transaction is okay. And even though the correct nonce value in the archive is 10, the nonce value on the ledger is 0. And so they can replay this transaction and maliciously use this nonce value. And so we have this challenging problem that for certain types of values, like nonces, there needs to make sure that you only have a single version of that entry between both the bucket list and the archive. This is a problem because the validators don't store the archive, and so there's no way of checking if a key exists or not directly from the archive. So that's issue number one. This thing like nonces, where you want to make sure there's only one version of the entry that exists. And then the second issue that comes up with security is something where you restore an outdated version of an entry. So similarly, let's think of a token where you have some sort of KYC entry, right? And so say that you have a KYC entry that allows a user to spend their tokens. And then that KYC entry isn't touched for a while, and so eventually it runs out of rent balance and gets sent to the archive. Now, a new KYC entry is generated on the bucket list, but this KYC entry revokes access to those funds. Now, let's say that this new KYC entry that revokes access isn't used for a while, and it too falls into the archive. What a malicious user might do is go into the archive and, instead of restoring the most recent version that revokes access, instead restore the earlier version of that KYC entry that gives the user access to spend those funds. And so by restoring an out-of-date entry, what you can do is essentially do a versioning attack, where you take an out-of-date entry, restore it onto the bucket list, and then you're essentially able to pretend as if it is newer than the KYC entry that revoked access. And so essentially, we have two issues we need to solve here. First, we need to make sure that you can only restore the latest version of an entry, so you can't do this like KYC rollback attack. And second, for certain types of data, we need to make sure that there's only one version that exists in the archive and the bucket list. Now, we don't need that guarantee, the uniqueness guarantee for all types of data. For example, the balance example I talked about earlier, it's completely fine if you have multiple different balances, but for things like nonces, you need to make sure you only have one. And so essentially, because we have these two different requirements, we expose two different types of storage at the Soroban interface level. Right now, we're calling this unique storage and recreatable storage. Now, essentially, the differences here is that unique storage guarantees that whatever entry you have, there's only ever one copy of. So in our nonce example, if you're using unique storage and you say, I use unique storage to create a nonce value, and that nonce value gets sent to the archive, if you try to recreate that value, the function will panic because it says, hey, this is unique storage, and an entry already exists in the archive, so I'm not going to let you to recreate that. Under the hood, how we do that, and again, this is an implementation detail for later, is we use a combination of proofs of inclusion and also proofs of exclusion. So for instance, whenever you create a unique data entry for the first time, you need to also provide a proof that this entry has never existed before. And so this proof needs to come from the archive nodes because the validators don't store enough information to prove that something never existed. But if you provide this proof to the validators, they are able to check the proof and make sure it is legitimate. And so because you have this extra step for unique data and needing to prove that an entry never existed, it's more expensive. Now, the recreatable data doesn't have this guarantee. And so for entries like nonces that have security implications, you wouldn't want to use recreatable data because you could have multiple versions of your nonces and you could recreate nonces and have security issues. However, you would want to use recreatable data for something like a balance that doesn't have this issue, because recreatable data is much cheaper. Because you don't need the security guarantees, you don't need to provide all these proofs of exclusion. And whenever you create a recreatable entry, you don't need to prove that's never existed before. And so essentially, we tried to provide these two classes of data so that users who need some sort of security guarantee can use the more expensive and slower unique data. But for entries that don't require those strict guarantees, you can use recreatable data. Now, in addition to these two data types, we also introduce a third storage type called temporary storage. And what temporary storage is it kind of just does what the name sounds like. It's entries that are meant to be temporary. And so essentially, if you have a temporary storage entry, whenever its rent balance goes to 0, instead of being sent to an archive, it is permanently deleted. And because you don't need to worry about sending this to the archive, and there's not this archival cost, the temporary entries are the least expensive storage type. Now, you wouldn't want to use this for sensitive data such as balances, because if a balance defaulted on rent, it would then be lost forever. But for temporary entries, such as if you want to give another user authority to use your funds for, say, 100 days, you could use a temporary entry that automatically deletes itself. Or if you had some sort of data that is easily recreatable, such as like a payment channel, you could also use temporary data for that, because whenever it was deleted, you could just regenerate the exact same entry again. And so these are the three data types and the storage mediums we're trying to present to the end user. Now, the issue is we have these security issues that are generated from the archive interface, and they can be very tricky to protect against. For instance, it's very tricky to think about examples like KYC rollback and nonce attacks in the context of this archive, especially since archival state is not only a new interface for Stellar, but a pretty new interface for blockchains in general. And so we want to provide an interface and define use cases as clearly as possible for each type of storage, and try to make this as seamless as possible for the end developer, and trying to abstract away as much of the complexity from the archival interface as possible. So I think this is a pretty tricky problem, but I think that's the high-level issue I want to talk about today, is just the security issues that arise from this archival state, and then the three types of storage that we've tried to implement so far. And so I think I'd be open to any questions, or if anyone has anything I'd like to talk a little bit more in depth about.
Thanks for that. Just a quick question. You were talking about unique storage and having to supply proofs. Does that mean that in order to create a unique storage entry, I need to have access to an archival node?
Yeah, so essentially how that works is when you actually, from the perspective of the validator itself, so yes, you do need to have access to an archiver node to produce these. And so kind of what we're imagining the interface would look like is that RPC nodes kind of double as preflight nodes and archiver nodes. And so during the preflight process, if you generate a unique entry, or if you want to access an entry that's in the archive, the preflight node itself will carry archival data. And so the preflight node will be able to essentially kind of work similarly to the footprint when it generates footprints for read-write data accesses, that the preflight node will be able to retrieve the proofs that are required for your transaction, and then give those proofs to the validator. And so because the preflight node is generating and providing these proofs, whenever you actually go to apply that transaction on the validator, the proofs are available because they've already been made in advance by the preflight node.
And just to be clear, for recreatable storage, I don't need that, right?
Yeah, so for recreatable storage, it's cheaper because you don't need to provide any proofs, and there's no work to be done. You can just, if a key doesn't exist on the bucket list, you can just generate that new key without any checks or balances, no problem.
Oh, to make an amendment, like it's not like nothing has to be done for creatable storage, because if you want to benefit from the fact that it's recreatable, you need to write some code that allows you to merge entries. For example, if you have a token contract and your balances are recreatable, you probably want to provide a contract function that allows users to recreate their balance given proof, basically. So it both involve something to be done, but in case of Unix storage, it would need to be done every time you create a new entry, while for creatable, it's only if your entry has got archived and you actually want to restore it, which hopefully shouldn't be the case too frequently.
Yeah, kind of the difference is in unique storage, if something exists on the archive, you must restore it. In recreatable storage, if the entry exists in the archive, you have the option of either restoring it or just, if the restore would be too expensive or you don't want to restore it for some reason, just creating a new entry with the same key.
But just to be clear, with regards to what Dima just said, if I do have an existing, if the ledger entry has been recreated with the same key, when I try to restore it right now, will it fail, or will it like use some sort of like custom merge capability? What's going to happen?
Yeah, so when it comes to recreatable data, there's a function that we define called unarchive latest version. And essentially how this works is whenever you restore unique data, it's automatically added to the bucket list immediately because unique data, because unique data is known to be unique. And so you know you won't have a key collision between the archive and the bucket list, so you can just automatically add it to the bucket list. For recreatable storage, this isn't true. There could be a key collision. And so whenever you restore a recreatable storage entry, it's not immediately added to the bucket list, but instead this function, restore latest archived entry, just returns the unarchived version, right? And so in the doc, if you look at the last 2 pages, there are 2 example functions on how to restore our recreatable data, 2 example implementations that a contract might do. But essentially, because of these key collisions, it's the responsibility of the smart contract implementation to resolve these collisions. And so, for instance, what you can do is after you get the restore latest or the unarchived entry returned from this function, you can check the bucket list and see if there's a collision. And then if there's no collision, the smart contract can just write the key immediately, no problem. But if there is a collision, then what the smart contract might do is compare the values of the recently unarchived version and the bucket list version and pick one or discard the other. Or in the example of balances, there could be some sort of merge operation defined by the smart contract. And so if you have 2 balances, the unarchived behavior might be, okay, take the unarchived version, sum the balances of the version that's live on the bucket list and the recently unarchived version, and then just write the result, which is the sum of those 2 balances. And so because there are different use cases depending on the contract, that's a contract implementation that this contract developer itself must think of.
And is there I see you have a section on default implementation. What should be the default implementation?
Yeah, so I think the safest default implementation is just if there's no key collision, i.e. if you want to restore something and there's no key on the bucket list, then you restore it and add to the bucket list. If there is a collision, just panic and fail. Because you don't want it to be a no-op because the unarchive function does delete the entry from the archive, right? Because you can't unarchive an entry twice from the archive. Once you've unarchived it once, it's gone forever. And so you won't want to lose entries if you can't, if there's a key collision. And so I think the safest option that preserves all the data is for the default. Just if there's a collision, just panic. And then you either have to wait for the entry that's on the bucket list to be archived or delete the entry yourself on the bucket list. And then the default unarchive will work.
Okay, I imagine there are a lot of questions. Unfortunately, we are at time. So this discussion is going to carry on. Feel free to ask questions on live chat. Garen, if you can hang out there and ask any questions and answer any questions, that would be great. And yeah, thank you all. This has been a very productive hour, and we'll see you all next week.